That was a little quiet for a second. Malia's not going to be happy about that. But audio is back. So we didn't cancel out either the natural logs because, well, the natural log of 7 does not reduce to a nice number. Natural log of 3 doesn't either. So we'll have these here, and we'll keep all this to the very end. Now, the next thing we're going to do is distribute. 2x times ln of 7 is the 2x times the natural log of 7. Negative 1 times the natural log of 7 is, well, just negative natural log of 7 is equal to 5x times the natural log of 3 plus 4 times the natural log of 3. Now at this point here, we need to get the variables together. We need to get the x's together, and we need to get everything else on the other side. Now how we move these really doesn't make a big difference. I can move the 5x ln of 3 over to the left-hand side, or we can move the 2x to the right-hand side. It doesn't matter which way we go, we just need to move them one or the other. So what I can do is subtract 2x ln of 7 from both sides. They do not, because they're two different terms. If they were the exact same, if they were both ln of 3 or ln of 7, then we could combine them. Because ln of 7 and ln of 3 are both two different numbers. They're just representation of a number itself. So these will cancel, giving us negative ln of 7 is equal to 5x ln of 3 minus 2x ln of 7 plus 4 ln of 3. Well, I could have done this all in one move. But instead I've done it in two. To get this here. So if we wanted to, we could have done these two moves in one go, moving them from side to side, or we can do them in two. Either way, we get to the same spot. Now the next thing is to get the x by itself. So we're going to factor it out of both terms. When we factor it out, we get 5 ln of 3 minus 2 ln of 7. And that brings us to the last thing we have to do, which is to divide both sides by 5 natural log of 3 minus 2 natural log of 7 on both sides. Because these here will cancel, telling us x is equal to negative 4 ln of 3 minus ln of 7 over 5 ln of 3 minus 2 ln of 7. And on the test, do make sure to include this as part of your answer, because I will check it and make sure that it's right. If negative 4 ln of 3 minus ln of 7 over 5 ln of 3 minus 2 ln of 7. Because we'll hit enter. Negative 3.95, so we're going to the nearest hundredth, so 2 decimal places, so negative 3.96. and especially on problems like this here on the test, I will check your answer first and see it. If it is incorrect, if I got a different number or it's not the answer that I'm looking for this here, the next thing I will do is check this here and see if it's right. Bless you. So if you did at least get x equals this here, and that is correct, I will give you the points for it, because going from here to here is not anything in solving. It's did you plug it in correctly, or did something, a sign error or something occur that the calculator didn't throw a fit about. So I will check this next if the number is not exactly matching up. Okay? So that should give you a little bit of relief, because getting at least to there, getting x by itself, will give you the correct answer just in case a calculation error occurs. Any other questions on 28? Yes. Now 29 is a little bit nicer than 28, because the first thing we need to do is get the logarithm by itself. So the first thing we can do in getting the logarithm by itself is divide both sides by 14, telling us that we have log base 13 of 2x minus 7 is equal to 5/14. From this point here, to simplify the log, we need to put both sides to the base of 13. Because 13 log base 13 simplifies out, leaving us with what's inside, which would be 2x minus 7 is equal to 13 to the 5/14. Now, if 13 to the 5/14 works out to be a nice number, we can simplify it. But odds are 13 to the 5/14 is not going to be a nice number, so we'll leave it alone. And just continuing to solve for x. So at this point here, we can add 7 to both sides, telling us 2x is equal to 13 to the 5/14 plus 7. And last but not least, we would divide everything by divide everything by 2, telling us x is equal to 13 to the 5/14 plus 7 over 2. And at this point here, we can plug it in. Fraction 13 to the 5/14 plus 7 all divided by 2 is 4.749 or 4.75. That's it. Questions on 28, 29? 30. Whenever we have 2 or more logs, we try to get one on either side, and especially in this case here where we have 2 logarithms and a number, we want to get the logarithms together. So I'm going to add log base 3 of 2x to both sides. Which those 2 is equal to log base 3 of 2x plus 6 plus log base 3 of 2x. We'll have one later, but if we have 2 logs on one side, 1 log on the other, we don't have any numbers that are not attached to a log or inside of a log. We want to get all the logarithms together, or kind of evened out on either side. We'll see one of those in a minute. But if we do have a number that's not inside of a log by itself, so the 2, get all the logs together, and we'll go from there. And the reason we do this is because of our addition property of logarithms. If we have 2 logs with the same base being added together, we can rewrite it as multiplication of what's inside the logs. Since they're both base 3, and they're being added, we can rewrite it as 2x times 2x plus 6 inside the logarithm. Now to simplify the log, we will put both sides to the base 3, because 3 to the log base 3 simplifies, leaving us with just 2x times 2x plus 6. On the other side, we have 3 squared, which is 9. Now we can distribute on the other side. 2x times 2x is 4x squared. 2x times 6 is plus 12x. At this point here, we need to subtract 9 from both sides, telling us that 0 is equal to 4x squared plus 12x minus 9. Any questions on this so far? I'm just curious. 44. Yep. And I think the back of the answer key tells us this is not a nice number. Plus 2x. Yeah, 2 decimals. Now, the reason I say that is I was just curious on this here, because b squared minus 4 times a times c gives us this here. Now, the reason I bring that up is because it means this is not factorable. So we have to use quadratic formula. All the ones on the test are going to be factorable or give us a number where you're not having to use the quadratic formula to solve them. So I'm negative 12 plus or minus the square root of 12 squared minus 4 times a times c all over 2a, which is 8. Of 12 squared minus 4 times a times c all over 2a. So all over 2. So we can type the whole thing in. Part of the reason I knew I could type the entire thing in was we already found out what the square root of b squared minus 4ac was. It's 12 square root of 2. It gives us a nice number. It works. It doesn't give us an imaginary 1. So we can type it in. Now what I did on the second one is I went back to the original equation I typed in, changed it from plus to minus to get our other choice, which is this here. Essentially the exact same thing. Except we have our negative. Now we can approximate this as a decimal, negative 3.62. And for our other case, right, 0.62. try to make sure that all these work out semi-nice, especially on the test, so you're not spending an extra amount of time, one, trying to factor, and then two, trying to go through the quadratic formula. But questions on this here? This one here. Now, if we notice that we don't, unlike the last one, we don't have a number by itself, we can combine these two. Because if we had two logs with the same base being subtracted, we can write them as one with what's inside being divided. Now from here, we have our 1-to-1 property. They both have log base 8, or really we can apply both to the base of 8, causing these to cancel, just telling us that we have 5x over x minus 3 is equal to x plus 4. Now the first step I would do, or next step I would do, is to multiply both sides by x minus 3. I want to get rid of this fraction, because these would cancel, telling us that we have 5x. On the other side, we would distribute this. We'd have x squared minus 3x plus 4x minus 12, which will just reduce to x squared plus x minus 12. Since we do have a quadratic, we can subtract 5x from both sides, telling us 0 is equal to x squared minus 4x minus 12. Any questions on how we got to this point here? Now at this point here, we could factor it, we can graph it. X squared minus 4x plus minus 12, yes? Minus 12. Graph, we have 2 points. Yep. So, second graph, we're looking for word 0. Well, we have a 0 at 6 and at -2. 6 and -2. Which one of these two is probably not going to work? -2. And if we plugged it back in, well, log base 8 of 5 times -2, even just this one here, we have log base 8 of -10. That's not going to work. So -2 doesn't work, but 6, if we do plug it back in, it will give us all positives, so we're good there. Any questions on any of this here? I'm going to come back to it. I want to do the 2 word problems first, and then we'll do it last. Both of the word problems that will be on the test, just like the review sheet, are all going to be involving PERT, A equals PE to the RT. I did put it in there so you have it on the review sheet, you have it on the test. This is what we're going to be using. Find the interest and round to the nearest tenth. One thing I will ask is that you do set the problem up first. And we're going to plug our values in. A, the amount is equal to our principal, our starting amount. And the starting amount for this is $2,500. E, so a $2,500 bond grows to $3,729.56 in 10 years under continuously compounding interest. Find the interest rate. So we have our principal E. They didn't tell us the rate, but they told us the time was 10.
Tristan, Art, come to the office. Tristan, Art, come to the office.
So I would start off with this here. Now we can start solving by first plugging in our amount, $3,729 in 56 cents is equal to 2500 e to the 10t. And at this point here, we're just solving for t. Now the first thing we can do in solving for t is to divide both sides by 2500. These will simplify, leaving us with e to the 10t. And over here we have $37,029, $3,729.56 over 2500. Now those two numbers will not divide nicely, so we'll leave them alone. The next thing we need to do is to simplify e, so we'll take ln of both sides. This side over here, the 10t will come to the front, and ln of e is 1. So it's telling us that 10t is equal to the natural log of $3,729.56 over 2,500. Well, the last thing we need to do is divide both sides by 10. Telling us, I don't know why I said t, but I'll explain that here in a second. $3,729.56 over 2,500, all divided by 10. And we can plug this in. ln 3729.56 over divided by 10 is 0.03999, or we can round this to 0.04. So our interest rate is 4%. So if it's asking for the interest rate, give it as a percent. If it's asking for years, we can just leave it as a decimal as we have it. And really, I know I labeled it as t, but it really should have been r, because we're looking at the rate, not the time. But it's not that big a deal if you do that on the test. I'm not going to count off for that. That's notation, not actual solving. So any questions on how we found the rate for this here? If 4,000 is put aside in a money market account with interest compounding continuously at 2.2%, find the time required for the account to reach 5,000, round to the nearest 10. So really the amount is equal to 4,000 E. Our rate's given to us, and we have to put it as a decimal. And this time we are indeed looking for T. We're not looking for R. So amount equals 4,000 E to the 0.022 T. So we're trying to see when the amount is 5,000. Equals 4,000 E to the 0.022 T. Well, the first thing we need to do is what? Divide both sides by. Those will cancel, leaving us with E to the 0.022 T. Does 5,000 divide by 4,000 nicely? Yeah, it's what? 5 over 4. If we can reduce it nicely, I would reduce it, because having to rewrite 5,000 over 4,000 continuously is not a lot of fun, especially if 5/4 is the same thing. Now we can take the natural log of both sides. Well, our exponent is going to move to the front, giving us 0.022t. is equal to the natural log of 5/4. And last but not least, we're going to divide both sides by 0.022. And we can plug this in to find the time. 5/4 divided by 0.022 is 10.1428. Nearest tenth is 10.1. And this is years. If we wanted to, minus 10 times 12. So it's 10 years and 2 months, almost, approximately. That's how long it would take it to increase $1,000. Not bad, but with most savings accounts, to really make a lot in interest, you have to have a lot of money in it. Yeah, as long as the interest rates hold. Now, this is the last one we're going to look at. Now, we can use U substitution on this, or we can factor it as is. So if we use U substitution, I'm going to set U equal to whatever the middle variable is, so here e to the x, which means in the middle we have 17u minus 63 is equal to 0. The first one, we'll have the 20, but it will be u squared. Now we could try to graph this and see if it gives us anything nice. 20x squared minus 17x minus 63. And unfortunately it does not. So we can factor this. Now our signs are going to be opposite since the third term is negative. Well, factors of the first and third term. One thing I know for sure is that I'm going to have u and u for u squared. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Out of all these, I'm going to try 4 and 5. Since we want the middle term to be negative, I'm going to set it up so that the bigger of the two factors of 20 will multiply with the negative, and the smaller of the two is going to multiply with the positive. 63. We have 1 and 63. 2 doesn't work, but we have 3 and 21. 4 doesn't work, 5 doesn't work, 6 doesn't work, but 7 and 9 do. Which one do we want to put the 7 and 9 with? Because that's most likely going to be the one that works. The others are going to be a little too big. We can try 9 and 7. And we can test this here. 5 times negative 7 is negative 35u. Plus 9 times 4 is 36u. That's not going to work. Let's try going the other direction. 5 times negative 7 is yeah. I was like, hold on. 5 times negative 9 is negative 45. 7 times 4 is 28. This here gives us negative 17u, what we wanted, yes? So that means we can set both of these equal to 0. Now, if we wanted to, we could replace u for e to the x at this point, or we can just leave it alone and finish solving. Minus one of the u's is equal to negative 7/5. Any questions on how we got through this here? Now again, we're using u in place of e to the x. So the last thing we need to do is plug it back in. Now for certain, I know one of these two is not going to work. Which one would that be? The negative, because if to solve for x we apply ln, this side here is going to be just x, because ln of b is 1, is equal to the natural log of negative 7/5. But we know we can't have a negative inside the log, so that's not going to work. We can do the same thing to the other side, which will tell us x is equal to the natural log of 9/4. I will take this here, and I believe for this problem I said I'd leave your answer, you can leave your answer in terms of ln, in terms of the natural log. So that's as far as you need to take it. Any questions on any of this here? Your test is